Hi folks, Joseph Kursky here at the Colorado School of Mines campus. Let's talk about what we will do in the GEGN 590 course. What will we do in week 1 of the course? The theme for week 1 is Geospatial Inquiry. Geospatial Inquiry. I salute you all for journeying forward in the area of geotechnologies. It is a journey, it's a lifelong journey, and I salute you for being on that path and wanting to learn more about it and to use it for a project, which is the focus of this course. I think it's important at this stage of the course here in week 1 to talk about in 2004, the U.S. Department of Labor identified 3 growing and essential fields for the 21st century: biotechnologies, nanotechnologies, and geotechnologies. And as you folks know, geotechnologies includes geographic information systems, or GIS, remote sensing, looking at the world from space, aircraft, or UAVs or drones, and GPS, global positioning systems, more broadly, global navigation satellite systems. So these 3 components make up the geotechnologies. Now, let's also review why GIS and what it is, ever so briefly, because I know you're already on that journey. One way of thinking about it is the traditional that you've probably read in textbooks and on the web: hardware, software, data, methods. Methods includes tools, models, and procedures, and most importantly, people. Another useful definition of GIS is a process-oriented one, and that really touches on the theme of this course. GIS is a system for collecting, managing, manipulating, analyzing, and presenting spatially referenced problems, issues, data. Another definition is a systems-oriented one. A GIS enables us to help capture, model, store, manage, and present complex systems. The world is a complex place, right, folks? In a problem-solving environment. That's really key, and that will help you in your project. How does the spatial perspective enlighten your audience? Your audience could be board of directors, county commissioners, your clients, your stakeholders, your advisory board, your fellow colleagues, etc. Why should they care about the issue that you've presented, and how does the spatial perspective help them to understand that issue and also be able to be empowered to make decisions that will help solve or grapple with that issue, if that makes sense? Now, another way to conceptualize GIS, of course, is to break apart its initials. The G part is the location component, right? GIS is spatially referenced. Everything has a real-world coordinate, whether it's a water well or a mine or a transportation artery, etc. They all have real-world coordinates. Now, these coordinates can be defined as a single point, a line, a polygon, or a starting point of a grid or an image. And the I, or in the information part, is the attributes, the informational database or databases behind the spatial data. It's usually stored as a set of related tables, as you know, in a geodatabase, a shapefile, some other structure. And it contains spatial fields, the latitude, longitude, street addresses, etc., and also aspatial or non-spatial fields, such as housing type or the number of people between 10 and 19 years old, the water quality, the outcrop, etc. And the system part, or the S part, links the G and the I together. So one can select a feature on the map in a GIS, right? Or conversely, select a feature in the table and have it be reflected on the map. So they work together. So the S part can refer to the joining of the G and the I, but also the S part can also refer to the analytical capabilities that GIS has. More about that in a minute. But spatial statistics, map overlay, proximity, routing, geocoding, and others. The S component ensures that a GIS is not just a set of graphics floating around in cyberspace, but the attributes are always linked to the map feature. Another thing I want you to think about as you work on your project is that GIS is changing. It's moved from a system of records, the geologic layers of this particular part of the Earth's surface, the water quality here, to a system of engagement where you're engaging with users, stakeholders, even crowdsourced citizen science, community science people. There are many ways that GIS is changing, and I will offer use some readings in this week to grapple with how it was in the past versus how it is now and how it will be in the future, along with some forces I want you to think about, some trends in GIS like artificial intelligence and 3D mapping and many others. Forces, trends, and then later on this term, I'm going to have you look at some skills that might be useful not just for this project in the course, but going forward in your career pathway. Also this week, I want you to think about the stool of geoliteracy. Geoliteracy requires cultivating three stools, in my opinion. Core content. So you need to know about a certain core content. Some of you are passionate about energy. Some of you are passionate about water. Some of you are passionate about natural hazards, sustainable development, etc. There's a large variety, I'm sure, in this course of interests, and I'm going to be interacting with you to find out what your interests are and encouraging you along your pathway. But there's core content. You need to be an expert in a certain area or areas. But also, you need to be skilled in using geospatial tools, including GIS, but also other tools, right? Statistical tools and field data equipment tools, etc. But number three, the geographic perspective. And you don't have to be a geography major, and indeed, that's not the focus of this course. But the geographic perspective pervades lots of different disciplines: health, business, natural resource management, energy, etc. The geographic perspective is looking at the world in holistic terms, that the ecosphere is connected to the biosphere, is connected to the atmosphere, is connected to the lithosphere, is connected to the hydrosphere, is connected to the anthroposphere, right, the human sphere. They're all connected. This very much ties also with traditional indigenous knowledge that the world is a set of interconnected spheres, that if you affect this component over here in this sphere, this component is connected also, and this is affected as well. So thinking about the world in holistic terms and also in critical terms. You need to be critical of the methods, especially in the AI era of GIS. You need to be critical of the data. How do I know if data is any good? And indeed, we'll spend time in the course talking about that. You need to be critical of the GIS software that you're using. Don't just take the defaults. Understand what happens when you change the parameters on whatever tool you're running in your GIS. In this course, we're going to be focused mostly on the ArcGIS platform, but it applies to other GIS platforms as well. So be critical. Have a spatially holistic, critical view of problem solving and about the world. If you foster the critical aspect, the critical thinking in this course, that is a noble goal. That's a noble goal and a noble outcome of this course. I also want you to think about spatial thinking, because that's going to affect your project. Spatial thinking has been receiving increasing attention over the past 15 years or so, and it was spurred by a National Research Council report on learning to think spatially, GIS as a support system in education. How do I define spatial thinking? Again, be critical of what you're learning. Look at other people's perspective. My definition is geospatial thinking, really, and it overlaps some with that geoliteracy stool that we talked about: skills, content knowledge, and the geographic perspective. But my working definition of spatial thinking is identifying, analyzing, and understanding the location, scale, patterns, and trends of the geographic and temporal relationships among data, phenomena, and issues. Identifying, analyzing, and understanding the location, scale, patterns, and trends of the geographic and temporal relationships among data, phenomenon, and issues. Now, why should we care about that? Because that pervades the focus of your project. And the last thing I wanted to focus on here in week one, then you'll get into this in the readings, but spatial analysis. You're going to do some analysis as you prepare your final project in this course. First of all, maps are more than reference documents, right? It's not just that these layers that you're looking at in the GIS are where something is, where a certain fault line is, or an outcrop, or a set of energy, wind turbines, or whatever it happens to be that you're looking at. Maps are more than reference documents. Maps have always told where things are, but in a GIS environment, especially nowadays, maps are a doorway to inquiry, So spatial inquiry, geospatial inquiry, is the focus here of this week. How do you frame a problem? How do you articulate that problem? How do you turn that problem into actionable recommendations? See what I mean? The spatial inquiry. Asking a deep question is really, if you get out of this course knowing how to ask thoughtful, geospatial related questions, that is, again, another noble goal. So maps are more than reference documents. They're doorways of discovery and doorways of inquiry. And spatial analysis, of course, is key to GIS. That's what distinguishes GIS from just some mapping tool. Spatial analysis. You don't do spatial analysis just because you can. You do it because it is at the heart of why we're doing GIS in the first place, and that is to make a more sustainable, equitable, resilient world, right? That's why we do GIS. We will practice our spatial analysis skills. How do we define spatial analysis? One definition from the International Encyclopedia of the Social and Behavioral Sciences is a research paradigm that involves a unique set of techniques and methods for analyzing events. Events in a very general sense, but that are located in geographical space. And related to my definition of spatial thinking, spatial analysis looks at the combination of layers and how they interact and affect each other, and then makes recommendations on more sustainability, more equity, more resiliency in whatever problem we're trying to solve. Another way of thinking about spatial analysis is to look at a poster that I'm going to have you examine this week, and that is 6 categories and 26 elements. And I'm not going to go over it all here. You'll read about it in this week's reading. But it's understanding not just where things are, but summarizing what's closest, the best route or path, the hotspots, the anomalies, the outliers, making predictions, predicting the what if. In sum, the successful spatial analysis steps are asking questions, exploring the data, analyzing and modeling things, interpreting the results, maybe repeat as necessary, presenting the results, and then making a decision. If not a decision, recommendations toward a decision. I hope that was helpful in our encapsulation of what we will accomplish here in week 1. I hope you find it interesting, relevant, and even fun. Speaking of fun, I've got a geo song for you. Some of you are new to GIS, and some of you are still mapping after all these years. Was still mapping after all these years. We'll see you in week 1. Glad you could join me for this course.